Namaste and welcome back to the JavaScript series, my friends. And I know it's been quite some time since we met, but don't worry, from now onwards, I will be extremely regular in my uploads, so don't have to worry about that. Today, we are going to be deep diving into our concept of promises. Of course, in the previous class, I had explained the concept of promises at the end of this particular video. So if anybody is coming directly first to this video, I highly recommend you to first go and watch this so that you have complete context about what I'm trying to teach. Anyways, we understood that primarily when we try to perform asynchronous operations in JavaScript and when multiple asynchronous operations are dependent upon each other, if we use the web API methods to perform asynchronous JavaScript, such as set timeout or set time or set interval, we end up in a particular coding pattern called as the callback hell, like this. I had explained this in detail. Callback hell, it's called as. The problem with callback hell is very simple. It's difficult to read, it's difficult to understand, and it's a very big headache if you try to debug this code. Because of the problems that they were facing, JavaScript introduced a brand new feature called as promises. Now, promises basically help you perform asynchronous operations, basically help you achieve this concept where two asynchronous operations are dependent upon each other, but at the same time, it will help you avoid callback hell. It will make your code easier to read, easier to debug, easier to understand, everything, right? There are multiple features that promises bring to the table. You can chain them. What I mean by this, I'll explain. Next, you can always, integrate it with async await. Now, these are also promises only, but a shorter way to write them. We will explore them. And of course, it provides you a better control flow management, which overall improves the readability and debugging ability of your code. Anyways, without wasting much time, let's directly deep dive into the concept of promises. All right, my friends, now let's begin by first understanding what a promise is and how it works from the memory point of view. Because like any other concept in JavaScript, understanding how it works from the memory internally is where the magic and the clarity lie. So without wasting much time, let's quickly create a promise, okay? Now, how does a promise look like? You always start by saying new promise. This is how you create a promise. Technically, this is called as a promise constructor. What is a constructor? We will explore in a later video, right? But all you need to understand is this is how you create a promise. Now, inside these brackets, you should always and always provide a function. You should provide a callback function to the promise. This callback function, which is given inside every promise, is called as the executor function. And I, my friend, will be creating this callback function. And there are multiple ways in which you can create a callback function. And if you're confused about callbacks, I highly recommend you to watch this video where I've explained callbacks in detail, right? Any which ways, coming back, since you're beginners, the easiest way to create a callback function would be using this function keyword syntax. I'll just call this as executor function, like this. Now, every single executor function further is going to be taking two inputs. And VS Code is only suggesting. One is called as resolve, another is called as reject. Resolve and reject, right? Resolve and reject are basically built-in functions in JavaScript which a promise can call automatically, right? So you don't have to create these functions. They already exist within JavaScript. You just have to pass them as input. So the first thing is, if promise is successful, then I will call a function called as resolve. If the promise is unsuccessful, I'll be calling a function called as reject. Am I clear? Great. Now this is my executor function. Now watch it. Inside this executor function, I'll just go and I will print one statement, console.log, and I'll just say inside executor function, like this. Am I clear till here? Now, if you do this, please try to understand, a promise is nothing but an object in JavaScript. And hence, one brand new promise object gets created. It's an object. What will be inside this object is a variable called a state. Now, this state can have one of three values. Either it can have pending or fulfilled or unfulfilled. The initial value of the state is always going to be pending. The promise is still pending. Either was it successful or unsuccessful, fulfilled or unfulfilled. Next, please try to understand, if it is fulfilled, then which function should get called inside the then function? What is this? I'll show you. If it is rejected or unfulfilled, then inside the catch, what is the function that should execute, which are callbacks. I want you to ignore this part for the time being. You'll understand when I explain. But is this state variable clear to you? Initially, what is it? Pending. Now I will come here and I will give this object a reference. I'll call it as PRM, promise, like this, PRM, right? And I'll just make it as constant. Just you can make it as let var or whatever you want. I'm making it as constant because I don't want this variable to point to anything else. It's a promise. I don't want it to change. Is this much clear? Beautiful. Now what I want you to understand is the moment you create a promise object, automatically always this executor function will execute automatically. What do you mean, sir, you may ask? Everybody should watch it. If I just go execute this, you can see I did not call this function. I did not do anything. It's just I've created a promise. But the moment you create a promise in JavaScript, automatically always the executor function will execute. This is the first point that you must commit to your memory. Am I clear till here? Now, please understand, how do you tell the user? Whatever is the logic of this promise, was it successful or was it unsuccessful? For that, we will be making use of resolve and reject. We didn't understand. Now try to watch this. If I come below here, what you must understand is, let us assume, now let me just clear this and close this up. Okay. Now let us assume, I'll now make this example a little bit easier for us to understand. Now let us assume one asynchronous operation has to perform, right? The entire concept why we reached promises is because there are asynchronous operations executing which take time, depend upon each other, callback hell, etc. Never forget. Now I want that asynchronous operation to be performed here. How will you perform an asynchronous operation? JavaScript by nature is synchronous. Even whatever this executor function also is synchronously only executing. But if I want asynchronous operation, I should make use of my web APIs. And my web APIs have given me something called as set timeout. Set timeout always takes two parameters. One is a callback function, other is the time. The timer I will give here is some 3 seconds. I'll give it as 3000 because it is in milliseconds. 1000 milliseconds is 1 second. 3000 is 3 seconds. Next, inside this, I want to give a callback function. This time, I will use this arrow function syntax. Understand what I'm trying to say? Now, inside this, what will you do? Now, let's take a simple example. For example, let us assume that, I'm asking water to be boiled. Obviously, boiling of water will take some time. So what I'll do is, instead of telling inside executor function, the moment I create this function, I'll just say water has started to boil. Water has started to boil. Now, obviously, boiling of water will take some time. That time only I'm simulating as 3 seconds. Obviously, in 3 seconds, no water will boil, but I hope you understood. Now, inside this callback, I will now say console.log, and let us assume inside this I will say water has been boiled. Now, if water has been boiled, that is a success. The promise was successful. Now, how do I tell the promise was successful? Very simple. On success, you should be calling resolve. On failure, you should be calling reject. Now I will just go here and this console spelling, I'll put one E here. Next, I'll come below this and watch it. I will now go and call this function called as resolve. I hope you understood. Now what happens? Now what happens means, watch this carefully. Now if in case I were to go here and execute this piece of code, look at the output carefully. Water has started to boil. That is my executor function. Then the set timeout. 3 seconds later, water has been boiled. Sir, then what about this resolve, sir? Now you should understand. On successful completion of the promise, resolve gets called. What does resolve do? Resolve will further call whichever function that has been provided inside then. We didn't understand, you may ask. What's this? Now see, promise. What is the name of my promise? PR. If this promise is successfully executing and resolve is called, dot then what should I do? Then whatever I should do is my wish. What I will do is, then also is going to take a callback only. And see, that is what I am also trying to show you here. If it was successful, then what should happen? Then will get called. Inside then whatever callback function you get will get executed. And what I'm going to do here is, I'll go inside then, and here I'll give again this arrow function syntax only. And inside this, I'll just go and say console.log. And here I will say promise fulfilled, like this. Am I clear till here? Very good. Now you should see. If I come, clear the screen, and if I execute it, water has started to boil, executor function. Then the set timeout, water has been boiled. Then I will call resolve. What will resolve do? Resolve will internally call my then. Inside then whatever callback function I got executed and I got promise fulfilled. Are we able to understand? Now let us assume during the boiling of water, it didn't boil properly. Then there was a promise fulfilled or unfulfilled? Unfulfilled. If it is unfulfilled, how to tell? How to tell means instead of resolve, please call reject. Now try to understand. If now I say reject, and now if I come here, clear the screen and execute, water has started to boil. Water has been boiled. Now the moment I printed this, water has been boiled, and when I called reject, you can see I got an error here saying, boss, new unhandled promise rejection. You didn't handle the promises rejection, because then will only handle success. Failure, if you want to handle, then watch this carefully. I will do one thing. After this, I will press enter here. Now, after this, watch it. After this, then I will say dot and say catch. So how you should look at it is, if promise was fulfilled, then do this. If promise is unfulfilled, then do this. Whatever you give inside catch is what will execute. Understand what I'm trying to say? Now here I will just come, and here also this will accept a callback. I'll give an arrow function syntax only. Let me just quickly duplicate this. Right? I'll put this inside and I will say promise unfulfilled. Clear to clear? Now if in case I were to go here, and if in case I were to clear the screen, and now if I were to execute, all of you are able to think, I feel. First, the moment you create a promise, executor function will execute. Then the asynchronous operation I performed. If it was successful, in this case, I'm assuming it is unsuccessful, I called reject. Then if reject is called, automatically whatever is inside catch, that callback executes, and I got promise unfulfilled. That's it. Am I clear to clear? Is this much clarity there for everybody? How this works? Understood? So one thing you must understand is, whenever a promise successfully executes, whenever you call reject, or whenever you call this one, which is your success one, whenever your callback is successful, automatically the state gets converted from pending to fulfilled. Whenever you call reject, automatically the state gets converted from pending to fulfilled. So that is how you must understand. Am I clear till here? So if this much clarity everybody has got, you got the fundamental idea of a promise. Now I'll come here, instead of reject, I will make it as resolve only. Okay. Now, I'm going to explain how this program works from the memory point of view. Everybody should try to understand what I'm saying. And this is where an average developer and a great developer's difference comes. And especially in the day and age of AI augmented development, where AI is going to write the bulk majority of the code for us. If the AI makes a mistake, if the AI starts to hallucinate, the biggest problem with people who don't really understand the fundamentals of coding but are just doing coding using AI is they are not able to debug because of the hallucination that the AI is doing. Some mistake AI would have done. So you should understand coding. Okay? Anyways, watch it. Now, first and foremost, whenever the program begins execution, JavaScript provides us something called as a call stack. Inside, it's always at any given point of time, only one thing can execute, synchronous execution. But in order to achieve asynchronous execution, JavaScript also provides us something called as web APIs. Your set timeout, set interval, clear interval. Also, it provides us two queues, two data structures, one called as a macro task queue, another called as a micro task queue. Now you'll understand how all of this actually works, okay? Watch it. When we begin our execution of our program, JavaScript sees that the programmer is creating a new promise object. Immediately it goes and it creates a brand new promise object, inside which it maintains the state variable. First, initially it will be pending. After which it will map. If the promise is fulfilled, then what is the callback that I should execute? If it is rejected or unfulfilled, then inside catch, what is the callback I should execute? It creates this object, gives it a reference. Understand what I'm trying to say? Now, please try to understand. All this, while this is happening, on my call stack, the global execution context is created. This I've already explained to you. First thing that happens is global execution context gets created. Then that is why all this code is executed, right? So your object got created. Now this is nothing new. All of you know this already. Now I want you to focus. Whenever a promise object is created, first thing that happens is automatically the executor function gets executed. Now this executor function is a function. If it is executing, it should be on the call stack, and hence its own execution context gets created of this executor function. Understand what I'm trying to say? Now, the executor function begins its execution. Now, when I come inside that, I'll get console.log, water has started to boil. Now, in the next line, when I say set timeout is a web API. Set timeout is a function which will not execute synchronously on the call stack because it is blocking code. It will block my operations. And hence, JavaScript will take this set timeout and register this callback in the web API with the timer saying that this callback has to execute. Timer is 3 seconds. In the meanwhile, you can see all the statements inside this executor function is done. Its execution finishes. Once its execution finishes, now please try to understand, control comes back to the execution context, that's the global execution context. There also you can see all the statements are finished. All this is related to the promise only, right? Even my global execution context goes. Now what happens is, while all this is happening, this counter is reducing. 3 becomes 2, 2 becomes 1. 1 becomes 0. Once it becomes 0, now this callback is taken and it is put into the macro task queue. Now, while it enters the macro task queue, please understand, we have one traffic police in JavaScript called as, can you recollect and tell me what is it called as? Event loop. I hope all of you remember the event loop and didn't forget him. This event loop is like a traffic cop. The job of this traffic cop is to see whether this call stack is empty. If the call stack is empty, it will pick one fellow waiting in this queue and put him inside. That's it. Now, since there is nobody in this call stack, what the event loop does is, it goes to the macro task queue, sees is there any callback waiting to execute. Yes, it is waiting. Now it will take it, put it into the stack. And hence now this function is executing. And what is this function? This function is nothing but this callback inside set timeout. Now once it starts, I will get console.log water has been boiled. That message comes, and next there is a call to resolve. Now, when you call resolve, what happens? Try to understand. The moment you call resolve, resolve takes the control to then and sees what is the callback inside then. It then takes this callback inside then and directly it will not execute it. Instead, it inserts it into the micro task queue. Friends, for the first time, you have understood the need or the reason why micro task queue executes. The micro task queue exists to store all the callbacks related to promises. Callbacks inside then, callback inside catch. All this is put inside the micro task queue. Understood? Now, why did this happen? Because this function was executing. Is there any more statements inside this function? No. Its execution context gets removed from the stack. Once the execution context gets removed from the stack, this event loop now checks, oh, okay, there is somebody waiting inside the micro task queue. Now it takes this callback function, puts it into the stack. And when it puts this function into the stack, what is that function? This function. And hence what will be the output? Promise fulfilled. Is there any more code inside this callback? No. Execution context gets removed. Call stack becomes empty, macro queue task queue is empty, micro task queue is empty, everything is empty, program execution stops, all memory deallocation happens. Am I clear? And that is why, look at the order. First you created promise, executor function executed. Once executor function, inside executor function, it took this set timeout, registered it. Once set timeout got the opportunity to execute, it then called resolve. Resolve then took the callback inside, then put it inside microtask. Then when it got a chance, it executed. Hope you're able to see. Now, if in case I come here and if I were to execute the code, water started to boil, executor function. Then the set timeout, water has been boiled. Then it called resolve. Then the callback inside, then executed. That's it. I hope this is clear. If it is not clear, I want you to rewind as many times as it is required for you to grasp whatever I've said, because this is a JavaScript series which is aimed at making you into a seriously good developer, an extraordinary developer, not somebody who just knows surface level knowledge. Understood, my dear friends? Is this much clear to everyone? If this is clear to everyone, on the building block of whatever I explained, let's go deeper into the concept of promises. Now, the next point I want you to understand is there are two queues here. One is your macro task queue, another is your micro task queue. Now, let us assume there are two callback functions waiting. One is in the macro task queue, another is in the micro task queue. If there are two callback functions in these two queues waiting, what is the order in which it will execute? Who is given more priority? Is it macro? Is it micro? Is there any logic behind this? Because understanding these things is what will help you debug your code later. Now, let me show you what I mean. Now, this promises code everybody understood, correct? What I'm going to do here is outside these promises and directly call one set timeout. One more asynchronous operation I'm creating. Now, please try to understand here what I'm going to do is I will give this maybe 4 seconds delay. Next, I'll give this a simple arrow function. Inside this arrow function, I'll just say console.log and I will just say maybe macro task like this. Understood? And whenever in an arrow function you have only a single line, these brackets are optional. I hope you're able to understand. Okay, great. I hope this much clarity everybody has got. Now, try to understand. We have a promise. We have a direct set timeout call. Now, when all of this is executing, a student who's new to JavaScript and many experienced developers also will get confused about how to trace this program. Let me trace it for you. Everybody should understand. First and foremost, what is going to happen? What is going to happen is I'm bringing all my memory segments in front of me. First thing that happens is my global execution context gets created. Inside my global execution context, primarily there are two main things happening. One is a promise is getting created. Another is I'm calling a set timeout. Now, obviously, from top to bottom, when execution starts, assignment RHS, I'm creating a promise. Promise object gets created. Everything inside this remains the same as previous. After which, I'll give it a reference called as PRM. Of course, this reference will be inside the global execution context, but I'm not showing it because then the diagram will become very messy. But I hope you understand this. Now, please try to understand, the moment you create a promise object, first thing that happens is its executor function gets executed. So the executor function's execution context gets created on the call stack. Next, I'll get water has started to boil. And then now I'm calling an set timeout function. Now, this is an asynchronous function, right? It will not execute inside my call stack directly. Instead, it gets registered inside the web API saying that this callback function should execute after 3 seconds. Not should execute after 3 seconds, should enter the macro task queue after 3 seconds. Execution depends on whether this fellow is free or not. Registering happens. Great. Now, as that countdown is happening, and you must understand, 1, 2, 3, it quickly happens, but I'm not showing that to you. Next thing that should happen is, again, now, please try to understand, I'm calling one more set timeout. Now, whenever you call set timeout, it doesn't execute on my call stack. Instead, this callback is now taken and registered. So, two callbacks get registered. One with a 3-second delay, another with a 4-second delay. Understood? Now, please try to understand, my dear friends. Executor functions is done. Now control comes back to the global execution context and nothing else is remaining in the global execution context. That also gets removed. Now please try to understand. 3, 2, 1. Obviously between the two registrations, first one 3 seconds will get over first. Moment it finishes, it enters the callback queue. The next one, which was 4 seconds, that time countdown also will get over. It will also come back to the macro task queue. So now there are two people. Obviously, queue means who came in first only will go out first. It's first in, first out. Understood? So now what happens is the event loop, my traffic police, will check whether my call stack is empty. Yes, it is empty. Now it will see, is there anybody waiting? Yes, it will take this callback, put it inside. Now this callback is nothing but this callback. Inside which I'll get water has been boiled and then who am I calling? Resolve. What does resolve do? Resolve will now go to then. And whatever callback is there inside then, it will not immediately execute. Instead, can you guess and tell me? What will happen is, it will take this callback and put it inside the micro task queue. All the callbacks associated with promises then catch is put inside micro task queue. Understood? Next, this function is done. Its execution context gets removed. Now you should focus. Now when you look at my program, there is a function, a callback waiting in the macro task queue. There is a callback waiting in the micro task queue. Now between macro and micro, which one will now get the first chance? Because anyway stack is empty. Traffic police is waiting for somebody to execute. But it is empty. Listen to me carefully. Every time a macro task, whatever is waiting in the macro task queue finishes execution, before the next macro task can begin, the event loop will always first flush out or finish everything waiting in the micro task queue. Yes. And hence, before going from one macro task to the next macro task, all micro tasks are finished. Keep this in mind. And hence the event loop will always give preference to my micro task queue. And hence this callback comes and it begins execution. And that callback is nothing but this fellow. I'll get promise fulfilled. After that, it exits my call stack. Again, my call stack is empty. Now the event loop will see, is there any more micro task queue waiting in the micro task? Clearly, you can see there is nothing. It shifts to the macro task. See, somebody is waiting, puts it in. And who is this? This is nothing but this fellow. Now I will get macro task. Understood? So this is a very important point. And to prove this further, I will now execute this. Water started to boil. Next, water has been boiled. Promise fulfilled. Then only macro task. So it works perfectly. So the point I wanted to explain is whenever in JavaScript, you have to go from one macro task to another macro task. Between two macro stack executions or the macro task executions, first all the micro tasks are completed, then only the switch happens to the next macro task. Clear till here? Very important concept. Very few people understand. And if you're genuinely enjoying this series, make sure to smash that like button and make sure to put some comments down so that I know that you guys are understanding the concept and you want more such detailed deep dive concepts, right? Is this much clear to everybody? Great. If this is clear, now let's move forward and look at the next part of promises. All right, I'm now going to start with the most important part of today's class, where you're now going to actually see the most important use case of promises, which is called as promises chaining. It is this promises chaining concept, which is why promises are heavily used in the industry in real time. Let me give you an example, okay? Let's take, for example, our e-commerce workflow. Now, what happens in an online shopping? First, the customer goes, they search and select a product. Only after searching and selecting a product, if they successfully can select a product only, next they should be able to add it to the cart and review. Only if successfully you can add it to the cart only, you can proceed to checkout. Only if successfully you proceeded to the checkout only, you will be able to place order and confirm, make payment, etc. So what you must understand is, each of these four steps are related to each other. They're related to each other. Also, what you must understand is, each of these steps should not be freezing the UI, should not be blocking the code, and must execute asynchronously. So there are four different asynchronous operations which are dependent on each other. This is the best way for you to implement promise, because it will make your code very easy to understand, easy to debug, and the flow of the code will become easy to understand. Whatever I said, if you want clarity on it, let's dive a little deeper, okay? Now watch this. I want to start by writing some code here for our reference. So, the four steps that is there in e-commerce, I'm just going to simplify it and create a function for step 1, right? Next, I will be creating one function for step 2, one function for step 3, one function for step 4. So please watch it. Here I will just go and say, this is my step 2, this is my step 3, and of course, this is my step 4. I have 4 total steps. Great. Now what should you understand? Now that you understood these 4 different steps, I'll write code inside that, don't worry. First, step 1 should successfully execute. Only upon successful execution, step 2 should happen. Only upon successfully executing step 3 and then step 4. And please remember, everything should execute asynchronously and should not freeze my UI. Correct? And that is why inside step 1, the asynchronous code which should execute will be achieved using a promise. So watch it. What I will do is, this step 1 is going to be such a function which will return, which will give back. What will it give back? It will return a brand new promise. I hope you're able to understand. Brand new promise. Now, inside every single promise, everyone knows what should be there, and execute a function. Now, since you understood the concept of execute a function, I'll simplify the syntax by writing it as a callback function, as an arrow function. Okay, so watch this. This is the syntax of your arrow function. This is nothing but your executor function. Now, you know your executor function will take 2 things. One is your resolve, and other is your reject. Right? Now, inside this, please try to understand. Simple statement. I will say console.log, and I will say, just give me a second. Let me fix my keyboard. Yeah. Inside this, I'll just go and I will tell step 1 started. Now, step 1 should actually execute, which will be a time-consuming process and hence should execute asynchronously. My UI should not freeze. So what I'll do is, I will now make use of one of my web API methods available to me, set timeout. Set timeout is obviously going to take two parameters. One is the delay. Let us assume some 4 seconds delay I'll give. Now there is a callback, which I will write as an arrow function like this, right? Inside this, I'll just go and say console.log, and here I will say that step 1 successful. If it is successful, what should I say? Resolve or reject? Resolve function I should call. Am I clear till here? In actual logic, there will be one if-else inside this. If a condition is satisfied, then I will call resolve. If a certain condition is not satisfied, I'll call reject. That is how we know whether it is successful or unsuccessful. Understood? Beautiful. Now, please try to understand. If step 1 is successful, only then step 2 should execute. Now, inside step 2 also an asynchronous operation should happen. That also should happen via a promise so that my code becomes easy to read and debug. So I will say return. And what will I return? I will be returning a brand new promise. Right? And everybody knows inside a promise, we will always be having an executor function. And this executor function is going to take two things. One is my resolve and other is my reject. Is this much clear to everybody? Now, inside this, one second, somewhere one extra bracket has come. Yeah, great. Now, inside this, what I'm going to do is same thing as I did before. So, I'll just go, I'll say console.log, and inside this, I will say step 2 started, right? After which the asynchronous operation will be performed using set timeout. Inside set timeout, I'll give this a delay of maybe 3 seconds. Then I'll be giving it one arrow function. Inside this arrow function, I will now be saying console dot, sorry. I'll say console.log, and I'll just say step 2 completed like this. Great. Understand what I'm trying to say? And if it is successful, what will we make use of? Resolve. Same thing should happen in step 3, and hence instead of writing the code from scratch, I'll copy the same thing. I will be pasting it here, right? Next, I will change it from step 3 started, step 3 completed. I'll give it some 2 seconds. Same thing should be happening inside step 4 also. So I will go here, I will make this as step 4 started, step 4 completed, and let's make this as some 1 second. So clearly you can see there are 4 individual steps, each which is a function of its own, inside which an asynchronous operation is being performed, but wrapped around a promise so that it becomes easy to trace the flow of my program, callback hell can be avoided, and most importantly, debugging becomes easy. Now you will understand the concept of a promise chain. Everybody should focus. Now listen to me carefully and look at the syntax and try to understand how it works. Tell me, logically think and tell me, what is the first thing that should happen? Step 1. So see, I will go and call step 1 function. When I call step 1 function, think logically, what is step 1 function returning? Promise. What is it returning? A promise object. Now remember the lecture correctly. Whenever you create a promise object, what happens? Executor function automatically executes. Inside that, whatever set timeout you have created gets registered and executes. Then either it will resolve or it will reject. Correct or not? So see, what I will do is, I'll come here and say, whatever promise step 1 returned, if it is successful, then what should I do? And see, I'll bring it to the next slide. Then what should I do? If it is unsuccessful, then what should I do? Then and catch. I hope you're able to understand what I'm trying to say. Now, please try to understand, if my step 1 promise successfully executes and this resolve is called, What will resolve do? Resolve will execute whatever callback I provide inside then. Reject will execute whatever callback I provide inside catch. Now you must logically think about the process and tell me if step 1 successfully is executed, then what should happen? Step 2. Now watch it all of you. What will then accept? Callback. I already have a function called as step 2. A function can be passed as input to another function in JavaScript. This is the concept of callback. Automatically it will call step 2. I want you to understand. Now think logically. Now once it calls step 2 is also a function only. Once this function executes, what is it returning? Promise, which is another promise object. Now, when a promise executes, automatically its executor function will execute. Inside that set timeout will execute. If it successfully executes, what will it call? Resolve. What will resolve do? Resolve will now come and check, boss, for this particular promise. If it is successful, then watch it. Dot, then what should happen? If it is unsuccessful, it will go to catch. Don't worry about it. But if it is successful, then what should happen? Think logically and answer. If it is successful, then what should happen? Step 3, which is another function which I have given as a callback. Step 3 is also going to return a promise. Whenever you create a promise object, executor function automatically executes, after which inside with set timeout will execute. If it successfully completes, what are you calling? Resolve. Now watch it. If step 3 promise is successful, then what should happen? If it fails, then catch. The same catch will work for all my promises. But you can see, first promise if it's successful, then chain it to the second promise. If that is successful, then chain it to the third promise. If that is successful, then change it to the next promise. And what is the next promise inside which function? Step 4. If that is successful, then what to do? If it is unsuccessful, then catch. Then what to do means I don't have a step 5. Instead, here I will give its own callback, which is an arrow function, inside which I will just say console.log and I will say all steps successful. And you know, inside an arrow function, if you have only one statement, brackets are not required. If in any of the promises issue happened, then I will come to catch. In catch, what I will do? In catch, I will just again give an arrow function like this, and there I will say console.log. And within this, I will say promise failed. This is called as promise chaining. Now, how does this work? Everybody understood the memory part of it. I'm just explaining directly the program flow. Listen. First, I'll call step 1. Once I go to step 1, I'll get the step 1's promise. Executor function will execute, step 1 started. Then it will register this callback set timeout with a 4-second delay. Very good. Next, what will happen is after 4 seconds, when this set timeout executes, I'll get step 1 successful. After that, I'll call resolve. When you call resolve, what happens? Resolve will then call the then part. In then part, which function are you calling? Step 2. Then in step 2, what will happen? Same thing. Promise is created. Executor function will automatically execute. Set timeout. You will register saying that in 3 seconds this should execute. After 3 seconds delay, this function will execute. Step 2 successfully completes. I will resolve. When I resolve, what will happen? Now that promises then will execute, which will then call step 3. Then that promise will execute. If it successfully resolves, then I'll call step 4. If step 4 also successfully executes and I call resolve, then it will come to then and this will execute. That's it. Over. And in any of the steps, instead of resolve, if I call reject, it will directly come to catch. Anyways, let's see whether the order works or not. Step 1 started. Once step 1 successfully completes, only step 2 will start. Then once step 2 completes, only step 3 will start. Then it completes step 4. Then all steps successful. Now watch this. If I were to go here now And if in case I come on top, watch this carefully. Let us assume in step 3, instead of resolve, I will say step 3 failed. Some reason it failed. Instead of resolve, I now call reject. Now you should understand the flow. Step 1 returns a promise. Whenever you create a promise object, executor function executes. Inside that, I call set timeout. After 4 seconds, it will successfully execute, call resolve. Resolve will now come and call the then part. Then step 2 will execute. Step 2's promise will now executor function will execute, after which the set timeout will execute. After 3 seconds, it will complete, it will resolve. Once it resolves, it comes to its then. Then what are you telling? Step 3. Now, step 3 also returns a promise. In that promise, executor function executes. Inside that, when set timeout executes, I'm saying step 3 failed and I'm calling reject. What will reject do? Reject will automatically go to catch. And in catch, what am I saying? Promise failed. Once control comes to catch, the propagation stops, the flow stops. Even if one of those steps fail, obviously this will fail. Understood? So watch this carefully. Step 1 started, then it is successful. Then it changed to step 2. Step 2 was successful. Then it changed to step 3. Step 3 failed. Once step 3 failed, promise failed. I hope this much is clear to you. This is called as promise chaining. And I want you to put the stack, the web APIs, the micro task, the macro task, the event loop, and I want you to trace this program. And let me see how many of you can do it. I hope you understood. So this is wonderful. I hope you understood about how, promises work, how resolve works, how reject works, how then works, how catch works, how promise chaining works. And you understood it from the memory point of view. I know this has been a long awaited class for many of you. And I am aware about all the comments you put in the section. I will be much more regular, I promise you that. Thank you so much for all the love and support you guys have been giving us. Make sure to like, subscribe and comment, and I will catch you in the next class where there is few more topics on promises which I still am yet to teach you. Stay tuned for more.